Is the screen sharing?
Yeah.
So question number 2 says blocks A of mass
Okay.
4 kilograms, B of mass 9 kilograms are connected by a light inextensible string. What does a light inextensible string mean? This statement, what does it mean? When you are connecting these two masses with a light inextensible string, what does it mean?
You mean a component?
I mean, I'm just mean this statement. What comes in your mind?
Tension.
Yes, there's tension. But that string, they are just telling you, ignore the weight of the what?
Of the mass.
Yeah, isn't it a string as mass?
Yeah.
So whenever
Mass.
you see that statement which says are connected by a light inextensible string, in other words, you just say ignore the mass of the what?
Of mass B.
Of the string, not of mass, but the mass of the string. So the blocks are held at rest on a plane which is inclined at an angle of 35 degrees. Blocks are held at a plane which is inclined at an angle of 35 degrees with the horizontal. So these are the blocks which are held by this string, which they are referring to, at an angle of 35 degrees with the horizontal. This is the horizontal. That is the plane which they are referring to. So ignore that mass. When you are doing your calculation, just focus on the mass of the 4 kg, focus on the mass of the 9 kg. Don't focus on the weight of the string. That's what they're just telling you. We know a string has also weight, but in your calculations, don't focus on the weight of the what?
Of the string.
That's what they mean only. A constant force F acting parallel to the plane is applied to block B. As shown in the diagram, the blocks now accelerate up the incline at how many? At 2 meters per second squared, which means that is our acceleration of the two blocks after applying a constant force F. The question now says, state Newton's law of motion in words. So from the Newton's law of motion in words, what does it say? Newton's second law of motion in words. Newton's second law of motion states that the net force, F net, net force acting on an object is what?
The object will accelerate in the direction of
the mass, and the object and its acceleration is directly to the mass of the object, and its acceleration, F net, is directly proportional to the mass and the acceleration. And x in the direction of the what?
acceleration.
Okay. So F net always x in the direction of the acceleration. So F net is equals to mass times what?
Acceleration.
So the statement which says the net force is directly proportional to. So first is directly proportional to the mass, this one, of the object, and its acceleration, which means also is directly proportional to what? To its acceleration. And this net force, it acts in the direction of the acceleration. So don't forget those 3 points. that this net force always acts in the direction of the what? Of the acceleration. So there are two things which are very important. It's directly proportional to the mass, directly proportional to its acceleration, and the net force acts in the direction of the acceleration. That is the first part. So draw a free body diagram showing all the forces acting on the block. Draw it and send to me on WhatsApp now. Draw free body diagram showing all the forces acting on the block. So I want you to draw the forces now and send me a picture on WhatsApp now. Just draw it on your paper, on your book, send a picture for these forces. So I'll be waiting. Once you have sent, let me know so that I open it. A free body diagram of the forces acting on the what? On the block.
So can I see the marks?
4 marks.
The marks for the free body diagram.
4 marks.
On the free body diagram.
I said 4 marks.
Oh, small this.
Four.
Wait. Oh, right. So I sent.
You have sent. Okay, let me open. Where's the picture now? All right. Is that your diagram, this one?
Oh,
Mm. What about the F applied? Where is it?
so it's they said for A, must.
You said what?
They said for A. For its tension there.
Yes, it's correct then. It's for A, then it's correct. So we are having FK
Mm.
kinetic friction.
Normal force.
Normal force, tension, and you indicate with an arrow. It's going down. Gravity. That's correct. Okay. Let's go to the next. Calculate the magnitude of the tension in the string and then force F. So let's go with, we calculate that magnitude of the tension in the string and the force F. So calculating the magnitude of the tension in the string. So for block A, the force acting parallel to the incline for block A is the tension which is upwards.
Mm.
It's like it's only the tension for block A. And the component of the gravity for block A is
M
G sine what?
Sin M M A M G G. It's not F G there.
M, not F,
G. I see G there.
which is the gravity. This is
Then
for A.
10,8.
For your A here, we are talking of the tension going in that direction. And then the component here, which they are talking about. Remember, this is your gravitational what? Force.
Mm.
When you resolve that force, it becomes the hypotenuse. And then, which means the one that is parallel to this force. Remember, when you are going up the incline, when you are going up an incline, the block A is going upwards. So as it is moving upwards, there is a frictional force, and also there is a gravitational force in the backwards. So which means it will be like this. The component, then there will be a parallel component like this. So this is what we are talking about, FG, the parallel component, which is we are referring to FG parallel. FG parallel component. Then this is the component that we refer to as FG perpendicular. FG perpendicular, this one. FG perpendicular. And this is the component that you are referring to as the gravitational what? Force. That is your hypotenuse. And this angle is the same as this angle, which is 30 what?
5.
35. Also, this one is also 35. That's how you draw your diagram. 35. 35.
Mm.
Mm. So the weight, how are the vectors? The resultant vector is FG. So it's made up of two vectors, which we are adding together. We are adding those two vectors. So which means it's this vector going down, plus this vector going in this direction. FG, that's why we are getting the resultant as FG. Always that resultant force is FG. So when you draw your triangle like this, mathematical, you know that the parallel, force acting parallel to the incline, this is the force acting parallel, the FG parallel. It's MAG, which is mass times G. G is the gravity. Mass times acceleration due to gravity. That's why you are going to get FG, force. Why you are saying, why is it not F sine theta? It's FG sine theta, which is mass times what? Acceleration due to gravity. Yes. For force A. Downwards, the direction is down. So it means in the negative side. If you take up as positive, that FG is always downwards. And also there is a kinetic what? Friction, which is also going in the negative what? Direction as well. Is that not so?
Mm.
So using Newton's law of motion, using Newton's second law for along the incline, F net is equals to mass times acceleration. That is our Newton's second law, what it says, which we have already defined. We have defined that F net
Directed
is
proportional
equal to mass times what? Acceleration.
acceleration.
Yes. So that is what we want to define here now. So what is our F net when we are talking about the second, dealing with the second block? We are having a tension, so we want to draw that one. So we are saying this. So let me put it nicely so that you can see. Our force is there. This is our block. Once I'm moving in the left and the right, the pull which I'm having for A is the tension, this side.
Mm.
And the pull which is there opposing the motion, there are two forces which are opposing the motion. It's not only one, there's another force which is also opposing the motion. There is FG parallel component,
And
which is,
FK.
and there is also kinetic what? FK, the one that you, there is also FK. You don't show FG parallel on the free body. You only show it when now we are calculating the tension. That's when you introduce that FG component of the gravity parallel. That is the one which is. So now these are the sum of forces. We say taking, what I always tell you, taking right, the right side is what? Is positive. Taking the right side is positive. All the sum of forces in the what? All the sum of forces in the X direction. All the sum of forces. They don't give you zero this time. They must give you what? The mass times the what? Acceleration. All the sum of forces in the X direction. So the X direction is your incline now. What is happening along the incline? This is your incline, which means on the incline here, we are having this. We are having a T. This is now my X direction. And then on the incline, I'm having this pull backwards, which is FG parallel. FG parallel. Also on the incline, I have F what?
FK.
FK. Now I have taken only the components. So this is what is happening here. So all the sum of those forces, they must give me, they must all equal to mass times acceleration. But we said we are taking positive, the right-hand side, taking the right as positive. The arrow is saying taking the right as positive. So which means the arrow of T, can you see the position for the arrow of T? Is going upward, which means, how do I write that T? It's a positive T. Then the other two arrows are facing backwards. That's why I am putting a negative, because of the sign. They are going where? To the opposite direction. So it will be minus FG parallel minus FK kinetic friction should give me mass times acceleration only for block A. That is that equation which is happening. Any questions so far? How we got that equation?
So, sir,
that's how you do, because this is now your X. This plane is now your X. That plane, what is happening? There's a pull and a push. So the pull which is going upwards, and then something that is dragging downwards. So you subtract. So everything that is happening there, according to Newton's second law, must be equals to mass times acceleration. If it was Newton's first law, everything must be equal to 0 because it's stationary. But in our case, it's not stationary, it's moving with an acceleration. That's why it's now equals to mass times acceleration. If it was Newton's first law, it's stationary, it's 0 because acceleration is 0. So you must understand those forces to know that now I am dealing with tension here. Where there is tension, you know, you put your T. This is the only pull for block A. If I am dealing with A, there's a pull, and there's a drag, which is the friction, and the gravitational force, which is only the parallel component. Should we continue?
sir, I have a question.
Yes, ask.
So, I understand that they say T is positive because it's upwards, ne?
T is positive because it's up.
So I have this question on this triangle, the FG and FG parallel.
Yes.
They are going in the same direction, which means what?
FG, which one?
Yeah, when they're going the direction, I think, the different direction. They're at the triangle that you drawn with the color.
And I can see it. So your question is what on that triangle? Ask me. What's your question?
Or what's happening when you draw this triangle?
Yes. What happens when I draw that triangle? When we are calculating the calculations, we remove, instead of using that FG, we are trying to get rid of that FG, that one. It disappears, that FG. We don't want it now in our calculation. So what happens? This FG disappears. How does it disappear? Because it's now contained in the FG parallel and FG perpendicular. So we are resolving that FG, splitting it into components FG and FG parallel. So that force now, it has no any effect. We have distributed it into a parallel component and a perpendicular component. So in other words, this force, we are no longer including it in calculations. It's out. That's how you do it. So that you only have the X components, X forces which are only acting in the X, and forces which are acting in the Y. So your Y will be the normal force, which is going to come here, like that, which will be your Fn. So that's why the Fn should be equals to mg, which is the Fg perpendicular, because these are the only two forces which are acting in the Y. So sum of all forces in the Y, there is no any movement in the Y, which means it's 0. That's why the Fn, the normal force, and the Fg perpendicular, they are equal. So once I know my normal force, Or if I don't know the normal force, I can know it by calculating only the component of the FG perpendicular. Then you know the coefficient of kinetic friction, where you know that Fn, normal force, is equals to UK multiplied by what? Coefficient of
Okay.
friction
Okay.
multiplied by
It's not F, F a normal force. Okay.
frictional force. How do you calculate frictional force? Fk. Fk equals
Fine.
coefficient of kinetic friction multiplied by the normal force, isn't it? Multiplied by Fn. So your Fn is just that one, Fg perpendicular, because they are the same. Then what you are not given is the coefficient of the kinetic friction. However, that won't stop us from calculating whatever that we want. Let's move on. I don't know if your question has been answered. That Fg goes. In our calculations, we are no longer going to deal with Fg. We only deal with Fg when we are just saying Fg parallel is mg, mass times acceleration due to gravity, sine theta, because Fg is opposite to 35 degrees. And the Fg perpendicular, we use cos because it's adjacent to 35 degrees on the triangle. Once you are done, then we don't use any Fg anymore. We are just splitting that Fg into components. Fg perpendicular, Fg parallel. Then you are done. For the horizontal axis, which means the x-axis, you only involve Fg parallel. For the vertical axis in the y, you include Fg perpendicular only. Those are the tricks. Then you'll be done. Once you split into components, that resulted, or that hypotenuse, that Fg which is going down, it disappears, it goes. We don't need it anymore. You only put it there when you are calculating the free body diagram, yes. But in the calculations where you want the values, you always use the components, not that magnitude of Fg. The magnitude of Fg is not going to help us. What is going to help us are the components, the X and Y components of that force of gravity. So ask if there is a problem, then I will clarify.
So like Mickey, we don't use Mickey because it's not the coefficient of kinetic rod.
Yeah. If it's given, you can use it as well. UK multiplied by N. UK, which means the coefficient of kinetic friction multiplied by the normal force. That is the value of the frictional force. But anyway, let's work it now. Then we can see if it's going to have an impact, isn't it? So let's have our G is 9.8 meters per second. Our theta is 35 degrees. The FKA, the kinetic friction of A, it was given. This one. The kinetic friction of A, it was given. Was it given? Yes, it's here. Can you see? Kinetic frictional forces, which means FKA and FKB.
Given.
Can you see that they are given respectively? So they made our life easy. So now it's a matter of just plugging in values. it was given. So let's go to the question. So which means here, where we are saying FKA, which means kinetic friction, we are going to put negative what? 5,88. Then FG parallel, it will be mg, mass times acceleration due to gravity, sine 35.
Oh,
Mass,
so the question is looking for tension.
the question is looking for tension.
Oh,
That's what we are calculating. Tension in the what? In the string.
mm-hmm.
Tension in the string.
So that's 3 minus mass of 4 kg goes to acceleration. Acceleration is 2. No?
Yes, calculate, then you see what you are getting.
FG, it's 9,8 sine, sine, sine 35
Sine 35, yes.
minus 5,88 for so I got negative, so
Your tension is what?
45,08.
45,08. All right, let's check. Isn't it here we are just putting T? What is our T? We don't know it. So you just replace everything. T minus. The mass for block A is 4.
Oh, I
The,
am 6.
then the mass for acceleration, the acceleration should be 9,8 sine 35 minus the frictional force is equals to mass times acceleration for block A. Then you just push everything to the other side. So solve now, you tell me what you are getting now. Are you winning?
Yes, sir.
Yes. What are you getting?
Plus 25, 48, 36, 33. I got 33,48.
That's the answer. Where is your mistake?
Mm,
33,48.
I think, yeah, there's a mistake here. Double check. Same 30, 30. Oh, yeah. And that's 50. So here it's giving me the 20 something.
Hmm?
It's giving me the because I'm punching it 9 comma sign sign 35.
Radians or it's in degrees, it contributes that. Check your setting of your calculator. Is it in radians or in degrees?
Mm,
Check it.
yeah,
If it's in radians or it's in degrees.
yeah, it's in degree mode.
And the answer is not coming out.
It's giving me 20 negative 28 comma 36.
So you are not getting that answer.
No, I'm not getting 22 because I'm subtracting when I punch it like that. You
Mm.
see,
Isn't
yeah,
it? We want t. T, we are just solving t, making t subject formula. In other words, we are saying t is equals to. So which means on the right-hand side here, already you are having 8. So it will be 8. Then the
um,
minus becomes the plus,
yeah,
5,8.
it's
Then
yeah, yeah,
minus
yeah,
becomes the plus, 4
I got
multiplied by 9, then multiplied by sine 35 degrees. What was your mistake?
yeah. It was the same. I
Yes,
did it.
the sign, they once you miss a sign, everything goes wrong. At least you manage to rectify your mistakes. That's what is important. Mistakes, they happen, but we are here to correct. So make sure the sign. Everything goes to the right, becomes positive. Adding everything. Okay. All right. So the next one, now we are calculating for the force F, which means for the force F, now we know the tension. So which means our block is like this now. So our free body diagram should be looking like for B. B, it's having a tension. At B, I also have what? F what?
FK.
FK, isn't it? And also block B, you also have FG what?
F
FG
parallel.
parallel. And also you are having what? F
F.
apply. Can you see what is happening?
Mm,
How many forces you are having? 1, 2, 3, 4 forces. So do you want to try it?
4 forces. Yeah, let me try it. So we're looking for force applied.
Yes. I'm looking for force applied.
Let me try it.
So I have drawn the forces. And then for B, now you know how to draw the triangle for B. You find only the component of the parallel, not FG. We are not using FG. We are using only the component of the parallel, which means it's mass of B multiplied by the gravitational force. Sine theta, which is sine theta, is still 35 degrees. Then you have the frictional force for B, it was given, and then you put your forces as they are, just like this. So F is the one going in the positive, so it's minus tension. So this, you are subtracting your T. F is positive, which means you are subtracting the T. Then you are subtracting, this is FG parallel for B. You are subtracting the what? The frictional what? Force. This should be equals to the mass of B, and they are moving with the same acceleration, which is 2 meters per second squared. So do the same. We are looking for F. Tension, we found our tension. You copy the equation, this one, so that I can open the values now where you are supposed to replace.
Yeah, so if I will do it.
Okay.
You can just go to the FK there up there.
But the equation, did you copy it?
Yeah.
In orange, which is easy to understand.
Mm.
Put the values. So which means here you need the diagram and the values which are there on the question. Everything will be there. The tension, remember, you have your value for tension 36, what?
36.
Yes, so put that value for tension, it's important. Then from there, we go to our diagram. We go to our diagram, which is this one. And we are told that the frictional force for a B, this is the frictional force for B, is 13,23 newtons. 13,23 newtons. That is the frictional force for B. So everything you are having it. You have tension. What you need only to calculate is the component of FG parallel for B. Once you know FG parallel for B, you are done. You can be in a position to calculate F. So let's go for it.
Yeah, so I got 118.
113 newtons.
18, yeah, 18,
Your
comma,
answer
118,
is 118,18
comma 18.
newtons.
Mm.
That is the force. Okay, let's just verify.
Oh.
Correct. That's excellent. Now you get the logic, ne?
Mm.
Now I can see the FG was giving you a problem. I have seen that one. The FG was giving you a problem. That FG, it disappears. You don't need it. Once you put into components, it goes. Do you hear me?
Mm. Mm.
Don't ever touch it again. Once you just resolve into components, which are X and Y, that FG which is going down, it goes, it vanishes. All right. So we'll stop here for today. We'll continue with our problem tomorrow. Tomorrow, I think we will finish 2 and 3. So don't
Mm.
worry. Okay. I have another class now.